Sketch on the complex plane the region defined by z take away 3 take away 4i is less than or equal to 5 over 2. Now I like to rewrite these, so it's going to be z take away 3 plus 4i and then less than or equal to 5 over 2, and that enables me to identify the point 3, 4. So we know it's going to be a circle and the radius is going to be 5 over 2, and then we're looking for the region inside. Less than or equal to means a nice solid boundary. So let's try and make a reasonable job of sketching this, because we're going to have to do other things with it. I might have to produce a second sketch so I can draw all over it in a minute as well. So we've got that, and then we've got 3, 4 would be sort of here, and the radius is 5 over 2. So I know the distance from the origin to 3, 4 is 5, so it's going to be about halfway there, and then 5 over 2 is going to come down here. Let's just try and make a reasonable job of sketching it, and I can almost see that I'm not going to do what I just said. So I think that's gone down too far. So I've probably gone too far over with that other point over there as well. And yeah, that's not too bad. Quite happy with that. We probably should label that that is 3 and that is 4 and that is 5 over 2. Solid boundary, and we want to shade inside. So that's great. For the region in A, find the maximum value of mod z and the minimum value of mod z. And remember, mod z would be the distance from the origin. Okay, I am going to produce a second sketch. I'm just going to pause while I do that so I can draw on the second sketch. So mod z is the distance from the origin. So if I draw a line straight through there, going through the center, that should give me the minimum mod z here. That's the closest point to the origin, and the furthest one will be on the other end of that diameter. Okay, so we know the distance from the origin to the center, because this is the point 3, 4. We know that distance is 5. It's just Pythagoras' theorem. Okay, so the maximum value of mod z is going to be 5 plus 5 over 2. So that's the distance to the center plus the radius, which is going to be 15 over 2. And the minimum distance is going to be 5 take away 5 over 2. Distance to the center take away the radius, and that is 5 over 2. We're then going to want the maximum value of argz and the minimum value of argz. That's definitely going to be a bit more difficult. So the maximum value of argz is going to be the angle, so that just touches there as a tangent. So the angle there. Let's just draw that back in. It's going to be that one, and then the minimum argz would be given by that. Now let's put the line from the center to there in as well. So in the first instance, let's go for the minimum. We're going to try and find that, but this is all symmetrical, remember. So let's also just drop a line down to there, but also let's drop a line to there so that we know it meets the tangent there at right angles. If I do the same on the other side, this shape is a kite, and we can make use of that symmetry. So we've got one triangle there that goes to the center, and so we know that length is 4, that length is 3, and the angle we're talking about there is this angle here. So I'm going to call that angle there alpha for the moment, and alpha would be the inverse tangent of 4/3. Now we can also find this angle just here. We have another right-angled triangle there. So that triangle goes like that. And we know this distance is 5/2 because it's that side just there. And we know this one is 5 because this is distance from the center, the origin to the center of the circle. And let's call the angle here beta. That's the one I've marked in red up above. Okay, so beta is going to be, remember this is opposite and hypotenuse, that is going to be the inverse sine of 5/2 divided by 5, which is the inverse sine of a half. And we know that one is pi/6 or 30 degrees. So the minimum argument is going to be the inverse tangent of 4/3 take away the inverse sine of a half. Just calculating that gives me 23.13 degrees, which is 0.404 radians to 3 decimal places. Now we said that this was a kite, so if we want the maximum argument, which is that one, then it's going to be the pink angle that we found here. That's the alpha, so that's the tan to the -1 4/3. But this time we're going to want to add that angle. So it's going to be add sine -1 half. And that gives me 83.13 degrees, or in radians, 1.451 radians.